Let's start our discussion by stating our overall goal. We are still looking at discrete linear dynamical systems. So systems defined in this way. But now we are going to look at matrices A with complex eigenvalues. And we're going to limit ourselves to the 2 by 2 case, just for simplicity. Before we begin, let's try to outline the general trajectory that we're going to try to follow here. We're going to introduce matrices of some special form. These matrices, let's call a matrix of this form C, are going to have complex eigenvalues, but they're going to be simple enough that it's easy to understand what multiplication by such a matrix does. And then we're going to make use of the previously seemingly very abstract material about diagrams commuting. So we're looking at a product like this, where A has complex eigenvalues. The way we're going to approach this is by doing an appropriate change of basis, and then looking at this transformation, which we've called T tilde. And actually, such a dynamical system remains in the same space. Rn gets sent to Rn. So this basis we use over here should be the same basis we use over here. We can do this with any basis, and we know that this linear transformation T tilde, because it's linear from Rn to Rm, is equivalent to matrix multiplication. The trick here is to choose a basis so that the matrix multiplication that goes from here to here is multiplication by one of these so-called special matrices whose products we can understand. And if we can do this, we'll basically understand this multiplication. Because remember that this is an isomorphism. These spaces are identical. These spaces are identical. And this transformation is therefore essentially identical to this transformation. So that's our overall goal.